This year, Microsoft and Google will spend close to $380 billion on buildings that almost nobody is allowed to enter. Not on software, not on advertising, on concrete, cooling pipes, and electricity. And last quarter, Google spent so much doing it that the company's free cash flow went negative. Negative $5.9 billion. One of the most profitable businesses in human history. Briefly burning cash. It did that on purpose. Inside those gray buildings is the answer to a question most people never think to ask. If a data center is just a warehouse full of computers, why is it worth more than almost anything else these two companies own? The answer is not the building. And once you see how these facilities actually convert electricity into revenue, you will start noticing it everywhere. In your inbox, in your spreadsheet, in every search you have ever typed. So let's follow the money. Forget the technical definition for a moment. The useful definition here is an economic one. A data center is a machine for converting electricity and capital into billable computing. That is the entire business. Walk inside one, and you will find servers, graphics processing units, networking gear, storage arrays, cooling systems, transformers, backup generators, and layer after layer of physical security. But here is the first thing that surprises almost everyone. The building is the cheap part. Researchers at Epoch AI modeled the full lifetime cost of a 1 gigawatt AI data center, roughly $38 billion to build. And when you spread that cost across the working life of everything inside it, about 60% of the total is the servers, not the land, not the concrete, not even the power bill, which means a modern data center behaves less like real estate and more like a fleet of extremely expensive trucks that has to be almost completely replaced every 5 years. Hold on to that. It explains something very strange that happens later in this story. Start with Microsoft, because Microsoft is the cleanest version of the model. Its data centers feed 3 revenue engines. Engine 1, Azure. Companies rent computing instead of buying it. Virtual machines, databases, storage, analytics, networking, and increasingly, artificial intelligence. In the fiscal year that ended this June, Azure crossed $100 billion in annual revenue for the first time, growing 43%. Microsoft Cloud as a whole reached $214 billion. For scale, Microsoft's total company revenue that year was $331 billion. Engine 2, Microsoft 365, Office, Teams, Outlook, OneDrive. Nobody opening a spreadsheet thinks, I am paying for a warehouse in Iowa. But that is exactly what the subscription buys. The software is the interface. The infrastructure is the product. Engine 3, Artificial Intelligence. AI is the most compute-hungry workload this industry has ever produced, and Microsoft sells that hunger straight back to its customers through Azure AI services, enterprise workloads, and Copilot. Now, here is the part people miss. Microsoft is not really selling computers. It is selling time on computers. A unit of capacity for a unit of time at a price, which creates an obvious problem. What happens when nobody is renting? Hold that question. It turns out to be the single most important number in this entire industry, and we are coming back to it. Google runs comparable infrastructure, but it monetizes that infrastructure in a fundamentally different way, and this is where the story gets genuinely strange. Start with the obvious half, Google Cloud. In the second quarter of 2026, Google Cloud generated $24.8 billion in revenue, up 82% in a single year. That is not a growth curve. That is close to a vertical line. Now the other half. Billions of searches run through the same infrastructure every day. Google charges users nothing for almost all of them. So where does the money come from? Advertising. In that same quarter, Google search advertising brought in $63.3 billion. YouTube ads added $11.1 billion. The wider ad network, another $7.3 billion. Roughly $82 billion of advertising revenue. In 90 days. And here is the detail that reframes everything. The same physical infrastructure serves both businesses. The same power draw, the same cooling, the same engineers. One set of buildings, monetized through 2 completely different mechanisms. Rent from businesses, attention from consumers. Microsoft's data centers have 1 door that money walks through. Google's have 2. Put them side by side, and the shapes become obvious. Microsoft, capital, into data centers, into Azure and software and AI, sold to businesses, producing subscription and usage revenue. Google, capital, into data centers, into search, YouTube, cloud and AI, sold to advertisers and businesses, producing advertising and cloud revenue. Same physics, same electricity bills, completely different customers. And if you take one idea away from this video, take this one. Neither company is in the business of owning buildings. They are in the business of keeping those buildings full, because empty capacity is the most expensive thing either of them can own. We are about to see exactly how expensive. But first, a question that has to be answered. Why does anyone pay them at all? A large company could build its own infrastructure. Some do. But look at what it takes on: upfront capital, land, power contracts, cooling, hardware refresh cycles, networking, physical security, specialist engineers, maintenance, and the hardest one of all, capacity planning. Guessing, years in advance, exactly how much computing your business will need. Guess low, and everything stalls. Guess high, and you have bought millions of dollars of equipment that quietly loses value while sitting idle. Cloud providers absorb that problem and spread it across thousands of customers. The textbook term is economies of scale. The practical meaning is simpler. One company eats the risk of the forecast, so nobody else has to. That is the real product. Not servers, certainty. But it only works if one number stays high. This is the part almost nobody explains, and it is the heart of the entire industry. A data center's costs are overwhelmingly fixed. The building was paid for whether it is busy or not. The servers lose value whether they are working or not. The cooling runs. The staff get paid. The security stays on. So picture a facility with capacity for 100 units of computing. If customers use 20 units, 80% of a multi-billion-dollar asset is generating nothing at all. The costs arrive anyway. Now push it to 80 units. Same building, same staff, same depreciation. 4 times the revenue. That is why utilization is the number that quietly decides everything. The cost of serving one more customer, on capacity you have already built, is remarkably small. The revenue from that customer is not. It is also why delays are so brutal. Industry estimates put the cost of a 60-megawatt facility running late at around $14.2 million a month, not in penalties. In revenue that simply cannot be earned, because the capacity is not live yet. Which brings us to the reason all of this went from a steady infrastructure business to the largest capital spending race in corporate history. Generative AI consumes computing at a scale this industry has never had to serve before. Training the models, and then, far more expensively over time, running them. Every response, for every user, forever. The chain is simple. More AI demand means more computing. More computing means more data centers. More data centers mean more capital expenditure, in the hope of more revenue. The numbers have followed. Microsoft has guided to roughly $175 billion of capital spending for 2026. Alphabet has guided to between $195 and $205 billion. In a single quarter, Microsoft spent $41 billion. Alphabet spent $44.9 billion, roughly double what it spent a year earlier. But here is the constraint almost nobody outside the industry sees. The limiting factor is not money. It is power. Data centers now draw around 6% of all electricity in the United States. Global data center power demand is running near 132 gigawatts, up from about 104 the year before. And in many American markets, the queue simply to connect a new site to the grid runs for years. Both companies have said the same thing, quarter after quarter. They are supply constrained, not demand constrained. They could sell more if they could plug more in, so they keep spending, which raises the uncomfortable question, what if it does not work? Because spending more does not automatically mean earning more. Look at the other side of the ledger. Capital expenditure. Land, buildings, servers, graphics processors, networking, power infrastructure. Operating expenses. Electricity, cooling, maintenance, staff, security. And then the quiet one that does the most damage. Depreciation. Every dollar of that infrastructure eventually flows through the income statement as a cost, year after year, whether those machines earned anything or not. Which is why one of the most consequential decisions in this entire industry happened inside a spreadsheet. Microsoft is extending the estimated useful life of its data centers from 15 years to 25, a change to an accounting assumption. And partly because of that update, its stated capital expenditure figure for 2026 moved from about $190 billion to about $175 billion. $15 billion. Same concrete, same servers, different definition. That is how much of this business lives in assumptions rather than in buildings. So why take the risk at all? Follow the customers. At Microsoft, businesses buy Azure. Enterprises buy Microsoft 365. Developers buy cloud services. AI companies buy raw computing. At Google, businesses buy Google Cloud. Advertisers buy Google Ads. Consumers pay nothing and are monetized through attention. And AI customers buy computing and models. Not one of them is paying for a data center. Every one of them is paying for what the data center makes possible. And now the number that answers the question we opened with. Microsoft reports something called remaining performance obligation. Revenue that customers have contractually committed to, but that has not been delivered yet. It stands at around $392 billion, up 51% in a year. Google Cloud reports a backlog. It reached $514 billion, growing by more than $50 billion in a single quarter. Together, that is roughly $900 billion of demand that has already been signed for, and that neither company has yet had the physical capacity to deliver. That is why Google let its free cash flow go negative. That is why Microsoft brought 88 new data centers online in 12 months. They are not building on hope, they are building against an order book. So why are two of the most valuable companies on Earth pouring hundreds of billions of dollars into buildings you will never see? Because those buildings sit underneath almost every digital revenue stream that matters. Computing becomes cloud. Cloud becomes AI. AI becomes software. Software becomes search, advertising, subscriptions, and years of recurring revenue from the same asset. Capital intensity, converted into an annuity. And it points at something worth sitting with. For 30 years, the technology industry competed on things that were effectively free to copy. Code, design, distribution. The next phase is different. It runs on land, transformers, cooling water, and grid connections. Physical things, in limited supply, that take years to build. Which means the company that wins the next decade may not be the one with the best AI model. It may simply be the one that got the electricity first. If that changed how you look at these buildings, subscribe to Industry Hidden Truth. We take the world's biggest industries apart and show you the economics underneath.